Just a minute, sir, we will start.
Sure, no problem.
Good morning to one and all present here. Once again, welcome back to the session 2 of day 4 of AICTE sponsored short-term technical program. So we are having Mr. Adarsh Natarajan with us today. Sir is the founder and CEO of Aindra. So Aindra Systems is an artificial intelligence driven company that is focused on creating diagnostic solutions for fatal illness. And sir has more than a decade's experience working in the technology industry, spanning various roles in multiple geographies. And others, sir's entrepreneurship journey started after completing his MBA from the Indian Institute of Management, Bangalore. His passion in leveraging deep tech to solve hard human problems saw him starting Aindra Systems. Sir is widely regarded as one of the early pioneers using AI for healthcare and specifically in the area of cancer detection. And he is frequently invited as a speaker in various international and national fora. He has been invited by Harvard, Forbes, TEDx, Unicom Conference at IIM Bangalore, and many more. He has been featured multiple times in international and national media publications such as the Economic Times, Harvard Business Review, Forbes, Your Story, and many others. He also mentors other startup founders in their journey. Keenly interested in entrepreneurship, he is closely associated with the entrepreneurial ecosystem through various forums like the Startup Leadership Program, a global entrepreneurship program for practicing entrepreneurs. He is a part of a closed group of entrepreneurs which experiments deeply in the areas of customer development using lean methodologies. When not innovating on new products, Adarsh sir is smashing it as a game of shuttle. He also loves traveling with his family. So on behalf of the principal, staff and students of the Department of Biotechnology, the Oxford College of Engineering, we extend your hearty and warm welcome to our AICTE STTP session, sir. Sir, the session is over to you.
Right. Thanks for a gracious and a long introduction, ma'am. Thanks for and to all the participants for taking time out to come and understand a bit of what we do in the space that we are in, and also try and get a little bit more understanding from a practitioner and an industry practitioner's point of view about where the technological trends are heading. And I'll try to, because I am in the healthcare space, we're using technology for multiple use cases in healthcare. I can, of course, talk a lot more on it. Apart from that, I will very briefly touch upon some of the use cases that we as a practitioners have been noticing how technology is making inroads into a traditional sector like agriculture as well, right? So I will try to first structure my talk in two parts. One is, of course, to give a very brief understanding of what AI, because it's been such a buzzword from the last many years. It would be good to kind of get some basic understanding of it in a common way, right? So that's something that I will attempt to do, the first part, and I will then dovetail how technologies like AI are being specifically used in the industry, like ourselves, in the healthcare space, and then I'll also touch upon how they're being used in the agricultural domain. Finally, ending off with some of my thoughts. So this is how I would like to structure the rest of the session, and probably the last 10 minutes or so we can keep it for conversations or any doubts that may come by. But I'll try and keep the presentation short and not too long. Right. So with that, I'll take this opportunity to thank you guys again, and let me get started without wasting any more of your time. Am I audible as well? Oh. I'm sorry, I'm just checking. Am I audible? Was my screen visible?
Sir, you are audible. Screen is not yet being shared, sir.
Oh, I shared it.
Now your screen is visible, sir. Sir, is your video is on? Sir, your slide is visible, sir. Sir,
Sure.
can you hear us? Yeah.
Yeah,
Sir, yeah. You can minimize this Teams screen and you can have this PPT screen. Sir. Yeah, sir. Now it's fine. Yeah. Sir, you are not audible. Sir, can you hear us?
can you hear me?
Yes, sir. Yes, sir. And now just minimize this Teams account and you can. Now, sir. Sir. Participants, there is some technical glitch at speaker side. He will be rejoining in a minute. Sir, can you hear us, Adarsh sir?
Yeah, I'm able to hear you. I'm so sorry for this. I'm not sure what happened, but I just got logged off. Uh,
No, sir. Can you please share your screens?
yes. Yes. Yeah, if you can now tell me if you're able to see as well as hear me, that will be very helpful.
Yes, sir. We can hear you as well as we can see the screen. You
Oh,
can.
all right. And I'm so sorry for the technical glitch. I don't know what happened, but nevertheless, let's get started. So, which also goes to say show that we may be working in any kind of deep technology, cutting edge technology, but it always will come with its glitches. So, having said that, if we get started.
Yes,
Um,
sir.
Yeah, so good morning all again. I, sorry for the delay, but I'm here to kind of talk about the buzzword that's going on from a long time in terms of some of the technologies that have been bandied about from the last couple of years, and that's artificial intelligence. And really, the question is for us all to understand whether is it all just hype or is it the reality behind the buzz that we see and hear in the markets around us, right? And there have been many technologies that are coming out every other day, but the biggest hype that we see right now, or the biggest buzz that we hear right now, is about artificial intelligence and how. At some point in time, there are some people who say that it will take over the world and all of that. So let's try and understand this, unpeel this a little bit more. So how I'll start is, as I was mentioning during my earlier, when I had joined earlier, I will first start with giving a few basic things idea about artificial intelligence. I know we are in the biotech department there, and we have a mixture of students as well as faculty. So nevertheless, it kind of helps to get all of us on the same page. Right. So let's start with the definition first, right? That's really the basic step in trying to understand something. What exactly is intelligence? And I'm not even going into artificial intelligence, and I'm going into what is intelligence in the first place, right? Once we understand what this is, then it probably understands the different flavors, whether it's natural intelligence or artificial intelligence, right? Now, there have been many definitions, right? And I will go through them one after the other, right? In the most basic definition, intelligence really is the ability to acquire and apply knowledge and skills that we learn, that we imbibe during our courses of life, right? So that is intelligence. There is again multiple different definitions. The second one just says it's the ability to analyze and adapt to different circumstances, right? Which means that there is a response mechanism that we have based on what is a stimulant around us. So the next definition that talks about is how do you analyze what are the stimulations around us and how do we react and adapt to those stimulations, right? So that they say is intelligence. Well, of course, one of the things that I liked about one of the definitions of intelligence that I like is coming from Einstein, who says that it's really not knowledge, but the ability to imagine, right, which shows the true sign of intelligence. And I just love this definition from Einstein because I think uh, putting this in the context of our later discussions about artificial intelligence, this sentence rings so very true that and which is why I love this definition myself, right? As we all know, since there are so many differing definitions, there is no consensus on one definition of intelligence. So essentially, it's almost like blind men trying to touch and feel an elephant, and then all of them describing their own versions of how the elephant looks like, and they're all wrong, and they're all right at the same time, right? So that's the thing about not having a consensus about what intelligence actually means. right? Now, while those are the definitions, let's get to the biology of some parts of it, right? And I'm sure you are more experts than I am in this area, right? Our human brain is divided into two spheres. We know that there's a left hemisphere and the right hemisphere, and this is generally how the different functions in the human brain actually are divided on the two hemispheres. So on the left hemisphere, we see all the, the logic, the strong reasoning power, the mathematics, the language, all of those analytical parts of how we think, how we function, all of that come from the left hemisphere. Whereas all the creative parts, right, the soft skills, the personality that makes us what we are, the ability to create something, the intuition, the gut feel, all our spatial abilities. So all of this come as part of the right hemisphere of our brains, right? So this is how the biology works. And I'm sure all of us know how we have neurons and synapses that keep firing electrical pulses, and that really starts off the process of ideas and transmitting certain thoughts, right? And how many neurons do we have in our brains? I mean, trillions of cells, right? I mean, just the number of zeros is mind-boggling, right? Now let's come to having understood a little bit about intelligence and a biology behind how our brain functions, right, with the neurons and synapses firing. Let's come to understanding a little bit about artificial intelligence. Now we come to the tech part. So what is artificial intelligence? Again, right? We start with the basic unit, which is defining what it actually is, right? Now, what one of the basic definitions says it's when we see an intelligent behavior in an autonomous agent, right? That's when we can classify that autonomous agent to be having intelligent, artificial intelligence and exhibiting certain amount of intelligent behavior. Now, where all do these apps? So while I'm just studying one of the most straightforward definitions of artificial intelligence, and then we start with understanding, okay, if that is really what artificial intelligence is, where all are they used, right? What are the application areas and how are they generally beneficial to us, right? And very broadly, right? Very broadly, whenever in today's world, at least as of now, right, in 2020, when we are talking about AI and what is it generally used for, this statement which states that whenever there is a need to predict outcomes based on prior data, this kind of encapsulates when an AI system is used in the world, right? So you can look at whatever applications that you can think of in terms of where artificial intelligence is used today, they'll all boil down to, or if you unpeel all of them, they will all boil down to this one thing, one statement, one problem statement, which is that if we need to predict any future outcomes based on past data that we've collected, that is where AI will come into picture. And we will, as we go ahead, we'll see how a lot of use cases of this particular thing comes into play, right? Now, so I'm just talking a few about now with that problem statement that we understood, what are the different areas that with this prediction need for prediction comes into picture, right? So we have when we talk about application areas on the right hand side, you have healthcare, autonomous vehicles, purchase predictions, and we're all exposed to both the health application of AI in healthcare already, though many of us may or may not know about it. AI today is making leaps and bounds and a lot of strides in the domain of healthcare. So you people from the biotech department are really sitting on an inflection point where you can see many of these technologies playing out a large role going forward. So it's a great time to be in the space that you people are. Of course, then moving on to the other area, we're talking about autonomous vehicles. All of us have heard of self-driving cars from Tesla, from Google trying out their own self-driving cars. Every car maker, every automobile maker in today's world is very seriously working and spending billions of dollars on creating these autonomous vehicles. And when I say autonomous vehicles, they don't only mean civilian automobiles. We are also talking about in the defense applications. We are talking about multiple different domains. So vehicles being autonomously driven, right? This is a big area again. Purchase predictions, I'm sure all of us have been beneficiaries of this. Whenever you shop on either online, on any of the online portals, you get recommendations of different other products that you may be interested in based on the past previous product purchases that you might have made, right? Or your friends might have made something, and because your friends share the same kind of personality as you do, you may start getting predictions of certain purchases that you can make, right? And that's one big area that there's a lot of AI that's going on in the under the hood. When it comes to virtual assistants, I'm sure again a lot of people, or a lot of us who use the internet for multiple different needs, are exposed in one way or the other to the chat bots that you see at the right hand bottom of your screen whenever you open any of the portals where they ask you, "Hi, how are you? How can I help you?" and all of that. So note that many of those virtual assistants are actually driven through AI. Not to miss out when I say virtual assistants, programs like Siri, Google on your iPhones or on your Android phones, all driven through AI at their core. Right now, for all of these application areas, what all types of AI applications are actually branches of AI are actually leveraged is what we mentioned, what I mentioned on the left hand side. So we use a lot of search, we use computer vision, NLP comes into play, a lot of contextual awareness comes into play. So all of these different, I would say, sub areas of AI, all either in conjunction with each other or separately play a huge part in the application areas that you see on the right hand side, right? So that kind of gives a small flavor of where all it is used in, what is the underlying technology within AI that is driving those application areas. Right now, let's get down to the how this is done, right? It's not going to get too technical, but just we will skim the surface to kind of give a flavor of how the how, right? Now, there are two ways that honestly AI can be achieved, right? There is a rule-based learning, right? And what does rule-based learning mean? It means that all the input circumstances are already clearly understood and known, and therefore what should be happening after understanding those inputs is also clearly understood. Well, which means that if A is the input condition, then B should be the output condition. So there's a very clear definition of what if an input is A, B, C, D, then output has to be X, Y, Z, right? So there's a clear mapping between what has to happen when, and if this is achieved, then that is the outcome, right? So that kind of a construct is called as rule-based learning. So where it's very simple, there are no variabilities, and therefore it is kind of fairly straightforward. The other part, how AI can be achieved, is through machine learning, and this is where again there's a lot of terminologies being bandied about in terms of machine learning, deep learning, and all of that. They're interchangeably used, but machine learning is the overall space within how AI can be achieved. Right now, what do we mean by machine learning? Now, machine learning is a way where you are teaching the computer or the processing or the computing unit an approach to solve a problem, right? So note the difference in how I'm framing this, right? The difference between rule-based learning and machine learning is, in a rule-based learning, everything is very clearly known. The input is known, and therefore the output is fair, follows a standard algorithm. If it is A, then X. If this is B, then Y, right? So things like that. Whereas in machine learning, what you're what we are doing, what we are attempting to do is we are acknowledging that we may not know all the input scenarios. We may have seen some kinds of inputs in the past,
But that does not mean that there are not going to be different inputs in the future. And therefore, what we do is try to model in a way such that, going by the past learning that you have, can the machine, can the algorithms, can the computer learn what has to be done in the future as well, right? So that is where we are giving a different twist to it, which means that we are only teaching the computer a certain approach of how to solve a particular problem and help it to learn along the way, right? Along the way, as it starts functioning, we teach it to then handle the future outcomes or future input variables, that so that it leads to certain kind of desired outcomes. So that is the whole difference of rule based learning and machine learning, right? And again, this is again what I kind of explained in my earlier slide. What is rule based learning? Rule based learning relies on a static set of rules to predict the future data. So this very well encapsulates what I had kind of explained, right? So, and again, going through the, simply, again, going through a textbook definition of what machine learning is and how I, fitting it back to how I explained it. So it is actually teaching machines. Machine learning is actually teaching those machines to make decisions in situations they've never ever have encountered before. But how do they do that? By actually an algorithm that learns from prior data, which then goes on to produce a certain kind of behavior, right? So essentially, it is learning from an observed data to predict a future data. That is, in essence, what machine learning does, right? Now, so while when we say machine learning, there are different techniques within machine learning, like different techniques. So why am I saying this? Because in today's world, a lot of the techniques within machine learning and the term machine learning are all used very interchangeably. But machine learning is a concept under which you have different types of machine learning, like support vector machines. There is regression. There is classification. There is deep neural networks. There is neural networks. So these are all different techniques under the machine learning ambit, right? And which is where it is important for us to use the right technologies, terminologies when we discuss with people, because that kind of is the right way to do it, right? Okay, now having said that, now what is very critical in machine learning? I'm sure all of you would have now understood that for machines to learn by themselves and do certain actions, what is very critical is data. Now, what is this data? The data is nothing but the past, the previous, or the historical knowledge that has been accumulated, which is then presented to the machine learning algorithms to learn or to understand about something. So therefore, a very, very, very critical component in any machine learning application is the data that is available to it, right? Okay, now, but is that all? Is all is data all that is needed? Obviously not, right? Why do we say it is not? Because no matter how much data is there, you can't really teach a cat to learn calculus, right? Because even though you have, as the picture depicts, there are so many books of calculus kept in front of a cat. It obviously can't learn calculus. Why is that? Right? Because the missing component of a model capacity. What does this mean in the earlier example? The cat needs to have the ability to assimilate this data, right? And that ability is what we call as model capacity. Now, what is model capacity? It's the actually nothing but the ability, as I was just explaining, ability of that particular model to represent the data that it has been presented with. For example, when we talk about a single a dot, right, and mathematically, how is a single dot denoted? With two parameters, right? So it's just a straight x and y. When we're looking at a line, you can see how different variables come into picture. When you're looking at a circle, now you see that the complexity has gone up, right? So what is it showing? That on the left hand side, you have right from a dot to a line to a circle, the model is And when I say the model is the ability to represent the data of a dot, right? So the model is slowly increasing in complexity, right? From a dot to a line to a circle. Now imagine you have to represent, a model has to represent a face, right? Now we are really talking about a million parameters that can go to represent this data of a face, right? Now you're talking about, a lot of dimensions of data, right? You're talking about, on the forehead, this particular face has two eyes, two eyebrows, a nose, two nostrils, two lips, two ears, black hair on the head, only certain portion of the head covered. This is the size of the forehead. So you can go on and on and on. And so generally, now you see that the model has exploded in complexity to represent a data here, right? So essentially what is happening is the model has tremendous complexity involved, and only when that model has that ability is when the data that has been presented to it can be of any use, right? And therefore, from my previous example, we now understand that complex problems need both more data and a very high model capacity, without which the complex problems cannot be solved, right? So this is where, going back to my previous example, the examples on the left hand side are in a growing order of complexity, the problem complexity. On Mr. Obama's face, if you represent it as set of data, you see that the model required to process this is very, very complex, right? Now, coming to what are neural networks, one of the topics that we spoke, or one of the tools that I mentioned available under the machine learning ambit, right? So, what are neural networks? Just to understand, just to kind of skim through this again, right? There are different theorems which say what is a neural network, but suffices to say, theoretically, the universal approximation theorem says that a neural network can theoretically learn anything, right? When I say learn anything, this is again the model that we were talking about. A neural net model can learn anything is what the universal approximation theorem says. So let's understand what that actually means, right? Now, how is it modeled, right? If you now remember the early point that I mentioned about the neurons and synapses and all of that, that is exactly how neural networks are modeled on, right? So it is actually following the biology of how the human brain works. So that is what the researchers have tried to do. They've tried to actually take the human, understand the human brain and draw parallels to it and say, if the human brain is able to process so much of data and solve very complex problems, how is it doing it? And what are the basic building blocks of our brain which allows us to do such high levels of complex problem solving, right? And they've tried to model an entity on our the way our brain works, and that is what they've tried to do it in a neural network, right? So you would see these are all different nodes which, well, similar to how we have a synapses and the firing, right? So you have layers. So essentially what we see is these are all, if you go back to my earlier example of how the biology works, and let me take you through that. So how the neurons and the synapses fire, right? So if you look at each of these things, assume these are the nodes that you see in the neural network. You see that they're all connected to each other. Every node will be connected to each other. And that is how a neural net is also modeled. Yeah, that is how it will also be modeled, that every node will be connected to the every other node, either directly or indirectly through the preceding or the succeeding node. So this is how a neural net is constructed, and I'm not going to get into the mathematical function of all these transfer functions and all, but suffices to say that it is, broadly modeled against how our brain functions. Right now, let's get to the other big change that has come by in the machine learning world over the last 3-4 years. So tremendous progress has been made in the world of AI thanks to this one topic of deep learning. And as I was saying, deep learning is one technique under machine learning. So this just to kind of get people familiar with that and kind of not deviate from that understanding, right? So deep learning is the other topic that we should talk about, which comes obviously under machine learning. So you would see, just as a word cloud that we've prepared here, what are the different use cases that deep learning has today has made inroads in, right? We're talking about right from social networks to clusters and e-commerce, consumer brands. So a lot of areas have been impacted by this tremendous improvement that came by thanks to the through how researchers, some very key researchers showed that deep learning brings in a tremendous improvement over other existing machine learning techniques, right? Now, what is deep learning? Right? Deep learning, how is it different from neural networks? So neural networks is nothing but neural networks, but with a key difference, right? So we've seen in the earlier example, this is how a simple neural network looks. There's an input layer, there's an output layer, and in between both of them, there is a hidden layer, right? Now, how a deep learning network varies from a neural net is in the number of layers that are in between the input and the output layer. Now, you would see in this example, there is an input layer at the beginning and an output layer at the end. But instead of just one hidden layer that we saw in a simple example of a neural net, now in our example, there are three hidden layers. Now, what does this actually mean? When data is presented to this input layer in the first level, it then passes it to the next subsequent layer. And at each layer, different features from the preceding layer are extracted out. So this process continues all the way till the output layer when the last classification or regression, whatever our problem statement is, happens at the output layer. When I say problem statement, it is meaning that if I give you this data, I need this output, right? So that's your problem statement, that's your requirement. So that is what is being met through this technique called deep neural networks. And deep neural networks are called deep because they have many layers in between the input and the output layer, right? So that's a very a brief definition of deep neural networks. So I'll just take a stop here. And is this level of understanding okay, or should we can we just move on, or rather would the audience like to understand more deeper about how it is done and all that? Okay, what I will do is I will just take a pause here and try to explain with an example of how a deep neural network would work. Is that fine? Would that work?
Yes, sir. Yes, sir.
Yeah. So let's take an example now and see how a deep neural network would function, right? This will give you some idea of how a deep neural network functions actually. Now, let us say the problem that we have, right, is to present an image to our computer algorithm, and we want the computer algorithm to tell us what that image is of, right? Okay, so if that is, and why is that required? Why is that simple? So for a human being, that's a very simple operation, right? So you look at a bottle, you will know it's a bottle very immediately, right? So why do you know it's a bottle? You're looking at features like, let's say, it has a certain shape, it has a transparency, it is made of glass, it has a lid, it looks like a bottle because there is some, it can hold some liquid, right? So these are all the different features in your mind that you have, which will then help you to classify an object in front of you as a bottle, right? Now the same ability of our brain to use those features or the learning of those features to then classify an object placed in front of as a bottle is the same ability that we want to give our deep neural networks, right? So that is essentially what we want our deep neural network to do. So presented an object, let us say, we want it to tell us what it is. Then what happens? So if in the input layer, at the input layer, this particular image has been presented. What happens is, as every layer it proceeds to, will extract certain features out of the input data that has been provided, or the data that has been provided at that particular layer, right? And again, going back to the example that I said, let's say if we present the picture of a dog, or a horse or a cat, right, to the algorithm, it will start looking at a higher level features to start with. So all the earlier layers will start extracting out all the higher level features. Now, what do we mean by higher level features? It could be simply saying that, in the example of a dog, the higher level features could be that the image in front presented to the computer algorithm has curves, or has straight lines, or has circles, right? Now, if you look at the image of a dog, I'm sure all of us can look at where there'll be many curves that we can actually mark on it. There'll be circles that we can mark on it. So even those are features that each layer will start extracting out, right? As they keep going, as they keep propagating towards the later layers, more and more advanced features are extracted out. More complex features are extracted out. As saying, okay, there is a retina, there is an eye, there is a retina, it is this big, there are whiskers, there is a nose. So every layer starts taking out more and more and more advanced features, and passing it on to the next, passing on the data to the next layer, right? And therefore, by the time it comes to the last layer, when it is ready to classify, we have extracted all the features out, and that is really the feature engineering part. Now, with those features is where the classifier is then passed. All these features are then passed on to the classifier. Now, what is a classifier? A classifier is nothing but an entity which will classify the data into A or B or C or D, right? That's what is called as classification. You are classifying certain data into certain buckets. Now, these features are all presented to the classifier and say, hey, you know what? In the input data that was presented to me, we have given you all these features. Now you figure out where it has to be bucketed or categorized under. Now, using those features, the classifier actually looks at saying that, okay, so if it has an eye, a nose, it has long whiskers, it has paws, and the ears are all floppy, if it looks like this. So the classifier has already been trained with understanding what those features actually can indicate. Now, based on what features it has got, comparing it with what features it has been trained earlier, it does a comparison and say, oh, okay, this is a dog. This is not a horse, right? So it will categorize it accordingly, right? So that is the whole process of how this deep neural networks works, and by feature extraction and then using it for classifying. So in a nutshell, this is how a DNN works, right? Now, imagine you are presenting a X-ray image, now X-ray image to this deep neural networks. Now we're talking about very specific use case where it is really useful in the real world, or you're presenting some pathological data to the deep neural network. What it does again, and what are you asking? Let's say you're asking, okay, in this image of an X-ray, of a chest X-ray, do you see abnormality A, B, C? Now that's the question you're posing to the deep neural network. What it does is it takes the input image of the X-ray image, goes through all the, as I said, different layers, extracting different features out, does its final comparison, the classifier does its final comparison, and then says, hey, you know what? On the right lobe of the lung, there is this ground glass opacity, and therefore, since the ground glass opacity as a feature was given to me, the classifier, I am classifying this image that has been passed on to me as something which carries an abnormality, something which is indicative of COVID-19, for example, right? So that is, in essence, how it works in real life, a real life actually example where any of these deep neural networks or any of these classifiers are being used for. right? So that I'm just so I'll take a pause at this time and say, is there any questions that are there from a tech perspective? Because I don't want to get too much deep into it, but I'm just trying to keep it neutral so that understanding is kind of easy to understand. So at this point in time, I'll just take a pause and say, before we move on to the next part of it, see if there's anything else that I can provide clarity on.
Sir, their mic is disabled. You can continue, sir. At the end of the session, we will be having the questions in the chat box. It is fine, sir. It is understandable. It's going good session.
All right. Okay, thank you. All right, so let's then move on to, now that we understand the mechanics of the underlying how the technology works. Now let us look at two of the topics that we wanted to kind of understand a bit about, and the applicability of this technology in these two areas. Right. First is the use of AI and IoT in agriculture. So I myself don't come from the agriculture back. I mean, in the domain that I'm working in. So I will very briefly touch upon it. But of course, when it comes to healthcare, I can talk a lot more. But right now, I can probably take you in a very quick journey through what I have seen, how AI is being used in agriculture, right? And I think this is something that most of us already know about, right? Today, farming is one of the sectors which is seeing a lot of interest because of multiple reasons. One of the primary reasons is that uh, agriculture has been largely untouched by technology. But then the question will be, so what, right? So what? So what if it has been untouched? Now, what is really driving the need for technology to be primarily aiding agriculture is that we've seen that the population growth is tremendous, the land remains limited, and therefore the resources are also limited, and therefore what we want to see is reduction in wastage of whatever is being produced, increasing the efficiency of what is available in terms of resources, and then ensure that all the resources that we have are optimally utilized to the best extent possible, right? And that is exactly the reasons why we will see a lot of adoption of technology in these areas. Now, what are the multiple different spheres in which we see IoT is making a play, right? And we already know that there are drones that are being actively used in healthcare. Soil management is again being done very actively to ensure water is used very optimally. The kind of fertilizers that are being used are also used very judiciously. We see that livestock management is one area where in fact the animals are monitored, tracked for their health, the quality of milk that they give, them, whatever, right? So all of those things are also being monitored and tracked closely. And then we also have precision farming telling us what are the kind of active monitoring of the farm that in question can happen, and therefore better outcomes can then be got through it, right? So you see that IoT has a lot of use cases right now that we see in agriculture, right? And this is again a simple thing of how it can be used, right? It can be looked at the soil temperature, and then maybe the moisture content in the soil, and then water can be provided. If not, if there's significant moisture already there, then you don't have to really again flood the farm with more water, right? And then there is ways of monitoring the soil quality in terms of pH, in terms of other chemical additives that are there, and then operate adequately in an optimal manner to ensure that the yields are maximized. So end of the day, we see that agriculture, which had largely been untouched, which was not a very, how do I put it, a glamorous sector to be spoken about when it came to use of technology. All of a sudden, we see there's a tremendous interest here. Why? Because of all the reasons that I kind of mentioned. I'm sure many of you people would have already, are kind of aware of how drones are playing a very key role in a lot of things. among which monitoring of these crops, monitoring of these of a field is one key area. Of course, you have drones doing a lot more than that because it's more of again a technology that can be utilized anywhere. But these are some of the big areas where we see AI making a play, IoT making a play, right? When you say going back to the example, you might be wondering, okay, what is the AI here, right? The AI really is in being able to sense what this, for example, any of these sensors are picking up, right? If the sensors are picking up the moisture level in the soil, the sensors are picking up, the physical sensors are monitoring the quality of the soil. Then what decisions have to be taken, right? Should the water be, more water should be released, or should water not be released? Maybe more fertilizer should be avoided. All of those decision making can happen through the AI systems, which take this data and then use the past data that they would have had. Probably, their algorithms would say that if moisture level is more than 80%, then the crop starts rotting, right? If that's a data point that they have, then those are the data points that go into making a decision for the future, saying that once it hits 80% or 60%, you should not water it more, right? So that's where the most of the decision systems have come by. I'm just giving some examples, right, of where all the decision systems come by and how are they aided by AI in the play. Now, when it comes to drones, a lot of computer vision comes into picture, and computer vision, as we should know, is also primarily driven through use of certain AI techniques. There's image processing, there is computer vision, all of it playing a role in understanding the visual data that we have picked up. Right. For in this example, maybe through an IR camera, this particular drone is picking up a part of the area where there may be more, I don't know, chemicals present or some heat generated here, which is indicative of a chemical, right? So those various kind of insights can be drawn once all of this is sensed, and then the AI systems are actually processing and analyzing the data that has been presented to them, right? So here the data is captured through a visual sensor, whereas in the earlier example, the data would have been captured through a physical sensor, which is measuring something else, right? So all these physical sensors detect different kinds of data, pass it on to the AI system, where AI plays a part in understanding, analyzing the data, and then predicting what needs to be done. So this, in a nutshell, is what I'll briefly touch upon in terms of AI and IoT in healthcare. And now I would like to kind of dovetail into how we at Aindra are using AI for in healthcare, right? So what we've developed is a computational pathology platform. And what do you and well, just to give a quick quick introduction, computational pathology. Well, pathology is the science of looking under a microscope at certain biological samples and determining what is wrong or what is working, what is right with that biological sample. That is pathology. Digital pathology is nothing but replacing the replacing the microscope with a digital image. Now, computational pathology goes even beyond digital pathology, where you're saying once the biological sample has been converted to a digital form, meaning that it is from it is now available in the form of a large image. Can you add certain computational means to make decisions based on what is presented to the computer algorithm through the digital image? So that is the whole domain of computational pathology. Now, the same thing applied in radiology becomes computational radiology. Now, radiology, when I say radiology, we're talking about radiographs like X-rays, CT scans, MRI scans, all those different types of scans, where again, we see a lot of activity, a lot of interest coming through, and a lot of products are coming here which specifically look at different conditions within these areas of radiology or pathology. Now, this is what we've done at Aindra consists of. I'm sorry, I'm just going to run through this. So we've developed a complete platform that allows us to detect certain kinds of conditions, certain kinds of critical illnesses at, let's say, even a physician's clinic, at a gynecologist clinic, at any small healthcare facility. So this ability of the computational pathology allows us to take healthcare closer to the people by making it point of care, right? So that's where our vision is. And of course, I'm just taking it through what all kinds of samples we deal with for people who understand a bit of these things. You will notice that every pathology has either tissues that are analyzed or blood that is analyzed or cells that are analyzed. So what this slide says is that we at our system is able to analyze all different types, right? And the first condition that one of the first conditions that we're looking at is cervical cancer, a big problem in India and in much of the developing countries. So this is one of the conditions that we are using AI to detect, right? And I'm just not going to go waste all of this. But anyways, now coming back to some of how does what does that mean, right? So what we see on the picture here is actually the image of cells that have been scraped from a cervix, from a gynecological examination. Now, what is a problem that we are telling our AI algorithms, right? We are telling, hey, you know what? I'm going to present to you a picture of a cell of a picture that looks like this. You tell me whether there is cancer in this or not, right? So that's the problem statement we are posing to the computer algorithm, and this goes back to my earlier example that I explained. Now the deep neural networks are expected to analyze this image and give out its call out. Is it normal? Is it abnormal? Right. So that's how we are using AI. These are some of the scales that we deal with, right? Are because we're not looking at a small image, we are looking at an image which has probably 10 billion pixels. So it's a pretty large image that we deal with, and there's always problems of quality. There is a variability that we have to deal with, which means the AI algorithm should almost become as robust as a human being's mind, right? If you look at these two images, a human eye in combination with our brain will be able to still say, okay, this is a cell also on the left hand side as well as on the right hand side. But imagine you show this to a child who's never been exposed to any of these things. So the child is going to struggle. Now that's exactly the analogy that your deep learning or your AI systems is like a child who's never seen things before and whom you are teaching to understand, analyze, and make decisions, right? So that's the analogy I'd like you to have in your mind. Yeah, so these are some of the things that we do and how we do it. How do we classify whether they're normal, abnormal, and all of that. So this is now coming back to our other product that I was talking about in terms of radiology, where we actually analyze X-ray images, chest X-ray images to look for COVID-19 and other things. Yeah, so we've been quoted multiple times by both national and international media. We've been supported by the government. So that's a little bit about what we do at Aindra. I will quickly now want to really talk about some of the learnings that I've had as an entrepreneur, because if at all there are some entrepreneurs or wannabe entrepreneurs in the room, these are some things that would be good to kind of have, right? Before we jump off, right? I mean, it is always good for us to understand what is it that we as entrepreneurs, and I'm talking about me as an entrepreneur myself, right? Need to have to actually really become entrepreneurs, right? And these are some of the things that are table stakes, which means these are necessary conditions for you to have as an entrepreneur and succeed, but not necessarily sufficient conditions. But these are necessary conditions. We should have a curiosity to learn, right? Because the rapidly changing technological landscape means that what is a bleeding edge and a cutting edge technology today can become obsolete in a very short period of time. The only thing that will allow us to remain relevant is our curiosity, which will allow us to learn about new things that are coming by, right? And don't and always question yourself as to why we are doing what we are doing, right? And again, the third point is about domain understanding whatever problem statement you are trying to solve, please get a complete domain understanding of that problem statement. Any peripheral understanding, take time to get an expert you can talk to, spend enough time, become an expert yourself, so that you get a proper great domain understanding. One of the things that we as entrepreneurs who just start off do is that we think that if we talk about our ideas, someone will steal those ideas and then they will become successful, whereas we will be left behind. Please, ideas are dime a dozen. It is really the execution and a lot of other things that matter. So don't hold yourselves back. Please discuss as much as you can. Talk to a lot of people, and that is what will give you early insights, and not someone who's going to steal your idea. If someone is going to steal your idea, and if they're going to take it all the way, then even you'll probably get to learn more about how they did it as well. So the opportunity size, the areas are very large. So do not worry about it. Please go ahead and discuss with as many people as you can. Lastly, the team is going to be very, very important. If any of you students here are thinking of starting off, please ensure you have a great team with you, because finally a substandard team is going to pull you down, is going to pull the startup down. So ensure that you have a committed team, a great kick-ass team. Right after you start off, and these were all before starting off, right? And after you start off, you please become aware of all the mechanics of how a startup is run. You need to understand finance, you need to understand marketing, sales, everything. Integrity, this is something that honestly should be taught in schools, in colleges, everything, right? What does this mean, right? It really means, as entrepreneurs, as people, what is our level of integrity, how honest we are with everything, right? So there is, this may sound like very cliched, but without integrity, I do not think any startup would go very far off, or any business for that matter. Right, so it goes to say that I cannot overemphasize this part about integrity. Now, coming to the other points of understanding, I think these are all very fairly straightforward. We need to have a good understanding of what we're doing. And the fourth point that I want to also touch upon is, what I've noticed is, all of us, and I'm guilty of it as well, is that we think very small, we think very local, right? We think only India. But please understand, until we aim very high and think global, our products, our thought process are all going to be very localized. And that is something that we really need to work on. And I think the last part about regulatory understanding is something that we can cover off specifically as well. Now, if any of in the group, in the audience, is thinking of starting off any AI, ML startups, some things that you need to really keep in mind. It is a very long journey in the AI, ML world if you're thinking of starting any startups here, because data is your fuel, model is your vehicle. Without these two things, you're not going to go from point A to point B. Now, it means both of them need equal focus, right? If you don't have them, then if you don't have either of them, then you're not going anywhere. If you have a great data scientist working with you, but he has no data, he's as good as being ineffective, right? If you have a lot of data, but you don't have someone who can make use of the data and build a model, even then you can't get anywhere. Which is why I said, if data is the petrol, the model is your vehicle. Without both of them, you can't get anywhere. Right now, what are the frameworks you need to? Whenever you're choosing something, once you have the data and the model, you're choosing certain technology to go ahead and implement those. Please ensure that you work with something that where there is a vibrant community presence, because more often than not, all of us in the industry lean on one another to help solve problems, without which it is extremely difficult and very low possibilities of success. Domain expertise. Now, all of us may not be experts in healthcare or in agriculture. So bring in the domain expertise early on. And the last part about ethics and explainability is, how, when you're talking about AI, ensure that these two aspects are kept in mind, right? We should be able to explain how our model is behaving and why it is behaving in a certain manner and giving a certain kind of output. That actually brings in a certain kind of trust in the system for our customers. Okay, so I'll just quickly run through this. Now, I've kind of told about what we do at Aindra and also what have been my learnings. Now, there's something called artificial general intelligence. What we right now have is what we also call as narrow intelligence, meaning if you give a specific problem statement, the models that we are building can do that specific job very well, but it does not have a general ability to solve, let's say, a problem of in agriculture as well as a problem in healthcare, right? Why? Because currently we don't have such a generalized systems available already. That is what is called as artificial general intelligence. And I'd like to take you through a small okay, yeah. So singularity, right? I mean, I will take you through a small video where we talk about singularity, but let me tell you what singularity means, right? And this is again a buzzword that you may or may not have heard. Singularity is a very interesting concept when we are expecting that at some point in time in the future, the machine intelligence will actually outstrip human intelligence and will go on to improve itself without any human intervention. I know it sounds exciting as well as scary, and that is what we will look at. So let me just take you through a peek into a possible future.
Hello.
Sorry. So let me just start this. Can you please tell me if you're able to hear this, and I will stop it in case you're not able to hear. Um,
You are dead center of the greater.
We can hear, sir. No issues.
you can hear? Okay, great.
Yes.
So I'd like you to watch this small clipping of a movie where the whole concept of singularity that I just brought about is very beautifully captured in a small trailer. So just look at it, and it is very interesting. Just sorry, let me start it again.
You are dead center of the greatest scientific event in the history of man. Hello. How do you feel about her? She's amazing. Every cell phone has a microphone, camera, and a means to transmit data. So I turned on every microphone and camera across the entire planet, and I redirected the data through Blue Book. My competitors thought that search engines were a map of what people were thinking, but actually they were a map of how people were thinking. Did you know that Nathan brought me here to test you? You're wrong. Wrong about what? Nathan, you shouldn't trust anything he says. Does Ava actually like you, or is she just pretending to like you? Self-awareness, manipulation, sexuality. Are you attracted to me? Now, if that isn't true AI, what is? Kayla, there's something I want to show you. Kayla, you have to help me. What will happen to me if I fail your test?
Right. So that was a small clipping about a movie where they actually show that the robot Ava in this particular movie starts getting consciousness, and then she starts getting that imagination. Now, if you remember the first very definition of intelligence that I was talking about, where Einstein says it's the ability to imagine things, right? That really defines intelligence. So, this particular, character, or rather the robot starts developing a consciousness and developing imagination, and starts using that imagination to manipulate the other characters. So that really is is to my mind a singularity moment, right? A singularity where machine is super intelligent. It is almost like another human being. You cannot distinguish from a machine to a human being, right? So that to me is a singularity, and I'm not sure whether we will see it in my lifetime, but I'm yeah, at some point in time in the future, that is a distinct possibility, which is why you saw many people really like Elon Musk, Bill Gates, Stephen Hawking, all of them talking about the potential power of AI, right, and where it can actually lead to. Now, that also means if we have such a powerful tool in our hands, it also means that we have to tread carefully, right? And that is what really brings in the concerns, right, of racism related to ethnicity, to related to geography. So essentially, having unbiased AI is something that is an absolute need of the moment. Now, why do I say that? Let me give an example. In the US, about a year and a half ago, or about a year ago, Microsoft got into a lot of problem because of how their AI algorithm, their image recognition AI algorithm had been trained. Now, it had been trained in such a way, the past data that was used to train it itself was a very biased data set. Now, what did that lead to? It led to a situation where a black Afro American was tagged as a ape, as a chimpanzee. His image was tagged as a chimpanzee, and it caused a huge legal furor for Microsoft. So Microsoft was penalized, and therefore they had to, and it got a lot of bad press, essentially leading to a significant business loss for Microsoft because of that one incident. Right now, why is that important, or what does that indicate? Right, it indicates that if your data sets are biased, you're going to end up in trouble. Now, let's imagine what would happen in a life and death scenario, right? If you would treat it, let's say you're trained your algorithms with a certain condition that's only seen in India, for example, right? For a certain particular, let's say, sickle cell anemia. And then we go and present that to a different ethnicity, and your AI misdiagnoses it. So the implications could be that certain medications are given to that person, which could lead to further complications, even morbidity, or in when certain uncomfortable situations, it can also lead to mortalities, right? So when we talk about ethics, it's not just about, okay, I want to have to keep my data set unbiased. It has real world implications. So that's a big thing that we have to keep in mind as we go along. And yes, right. Why would we trust our lives on AI unless it does not fail at all, right? And that's where we have to bring in mechanisms to ensure that the trust in AI goes up, and that's where explainability, one of the topics that I spoke about. How do you ensure that you're able to explain how our AI behaves to an outsider, actually determines how trustworthy it becomes, right? And there are a lot of things, right? Can I, what are the security mechanisms and all of that? So these are all different concerns that I've kind of brought about. And finally, a very dangerous thing that we've seen is much of this technology can be weaponized, right? We see drone swarms that are already becoming a reality. Drones are the ones which will be probably fighting the wars of the future. Robots are the ones which will be fighting wars of the future. Now, imagine, because of how the AI system has been constructed, they go around shooting, I don't know, South Indians, for example, right? that wouldn't be a good thing, right? So essentially, a lot of these concerns come into picture, and because it's such a powerful tool, it also means that we have to be very, very careful about how we use many of these technologies. That's a closing thought. I will part with this. In my mind, AI isn't really the rise of the machines, but I think it's actually the machinification of humans, right? Where we humans start having elements of machines within us, and therefore we start becoming, in a way, machinified as well. Right, so I'll leave you with that. I know it's been a very long talk. Thanks for patiently listening in. I thought I should be able to end it in an hour, but I was not able to. My apologies for that. And if there are any questions, I'll be happy to take them. And hopefully, this session has been of some use to people. You've been able to get a bit of an idea of what it is. And yeah, over to you, ma'am.
Thank you so much, sir, for this wonderful and valuable information. Participants, if you have any queries, you can unmute yourself and talk to sir, or you can post your questions in the chat box. Sir will be with us in for few more minutes. Sir, I have a question from our end. Is there any internship opportunities will be provided to our students?
Yeah. So, what is a period of internship that is currently?
3 to 4 weeks, sir. 1 month.
Generally, to be honest, the period is very small for students to be actually working in this area and then being able to learn anything and then contribute. So my recommendation also to the college would be that it would be great if that period can be extended.
Okay, so if it's a long
full
duration,
learning will happen.
how much minimum duration you will be providing, sir? According to you, how much minimum duration is being required?
We would think at least 3 months is required for the students to learn something useful that they can make use of.
So can them do that as a project, sir? If there it is a 3 months, so if that internship can be converted into a project.
Yeah, we can do that. Yeah, if that's a project, then a minimum of 3 months and up to 6 months is also fine. So yeah, that's where I think it will be most useful.
Okay, sir. Participants, please, if you have any queries, please post it on the question chat box. Sir, it was a very wonderful and valuable information and a very elaborate explanation you have given regarding to that artificial intelligence and how we can implement that with respect to IoT in agriculture. So once again, on behalf of the principal, staff and students of the Department of Biotechnology, we extend you a very heartfelt gratitude for accepting our invitation and giving such an excellent talk, sir. Thank you, sir.
Thank you. Thanks, everyone. Thanks for patiently listening in, and good luck to all the people here. Thanks a lot.
Thank you, sir. Thanks.
You take care.
Sir, you may kindly log. So dear participants, we are winding up with the session 2 of day 4. So we will be rejoining as 2 for the session 3. So please do rejoin with us at the session 3 at 2 p.m. So we are officially winding up the session 2 of day 4 with the kind consent of convener. Thank you. Please join at the exact time. Attendance is being monitored and the certificate will be provided based upon the attendance as well. And yesterday's speaker, Dr. Colonel Venkat, Director AICTE, is also joining us for the session. So please do join at that. Thank you.